Something wild is happening in the AI world right now, and it's not just hype. DeepSeek just dropped a new way to make AI models teach themselves how to think better, and it's starting to outperform giants like GPT-40. Meanwhile, OpenAI is cooking up a bunch of new models and just gave Chad GPT a serious memory upgrade. It can now remember everything you've ever told it. Yeah, things are moving fast, and it's honestly like talking to an AI that grows with you day by day. Now, before we start, quick heads up, we just dropped a free course on AI avatars, what they are, how to use them to speed up content creation, pick the right tools, and even make money with them. Spots are limited, so check the link in the description and grab your spot now. Alright, now let's talk about DeepSeek's new AI system. They call it DeepSeek GRM, and they say that once an AI model is trained with SPCT, it can handle single, paired, or multiple responses with ease. So let's say you give the model several possible answers, it will churn out a little piece of text that shows its principles, basically the rules it's learned to judge what a good answer looks like, and then it critiques each answer in detail before assigning a score from 1 to 10. If the answer meets its criteria for correctness, clarity, safety, or whatever else it has decided is important, it'll get a higher score. If the answer looks dodgy, it'll get a lower score. But here's what sets it apart: it can do something called repeated sampling at inference time, meaning you can sample the model's internal judging process multiple times and either average out or vote on the results. That might sound a bit time intensive, but it leads to more accurate final decisions because you get a broader distribution of possible critiques. As an extra step, they introduced a sort of gatekeeper called a meta reward model, or METARM, that filters out any subpar critiques the system might generate, so you don't need to just trust one critique. You can gather several, filter out the nonsense, and end up with a better final decision. Now, let's take a step back and explore how they trained DeepSeek GRM. The process is called self-principled critique tuning, SPCT, and it happens in two phases. The first is rejective fine-tuning, RFT, which aims to give the model a baseline sense of what good critiques look like. This phase uses 1.07 million pieces of general instruction data plus 186,000 items of rejectively sampled data. The idea behind rejective sampling is that if the model's predicted scores don't align with the known best responses, those generated samples are tossed out. If everything is somehow correct right away, they discard that as well because they want to focus on challenging examples. They also throw in some single response data labeling correct responses with a 1 and wrong ones with a 0. That's the training set for the baseline. They say that for their 27 billion parameter model called Gemma 227B, they used a batch size of 1024 and a learning rate of 5 times 10 to the power of 6 training for about 900 steps on 128A100 GPUs. That took them close to 19.2 hours. Then after RF, they do the second phase, which is rule-based online reinforcement learning, using something they call GRPO. Similar to PO, it compares the model's predicted best response to the actual best response, awarding a reward of +1 if it matches and -1 if it doesn't. They also incorporate a KL penalty of 0.08 to keep the model from drifting too far off track. This phase uses 237K data points and runs for 900 steps with a batch size of 512, also on 128As for about 15.6 hours. DeepSeek has also tested different sizes of this generative reward model, from a 16B version built on a mixture of experts foundation to a 27B version built on Gemma 227B to massive 236B and 671B. Versions also employing mixture of experts architectures. They keep pointing out that the default size they showcase results for is 27B, presumably because it offers the sweet spot of performance and cost, but they do say that if you try enough repeated sampling at inference time, you can get the 27B models performance pretty close to the single pass performance of the 671B monster. That's a big deal because scaling up to a 671B model is obviously more expensive and hardware intensive, whereas sampling a 27B model 32 times might be more feasible in certain use cases. Is basically a statement that if you want to do this in a real-world pipeline, you might not always need to jump straight to the biggest model to get top-tier results. The real highlight is how this approach performs in benchmarks they tested across multiple sets like Reward Bench, which looks at chat safety and reasoning. There's also PPE, which has preference and correctness parts, and RMBB for helpfulness and harmlessness tasks. Then there's RM mistake for single response or error detection for Reward Bench. The 27B version of DeepSeek.grm gets about 86% with a single greedy pass, which is already pretty high. Then if they do something like 8 sample voting, that jumps to about 88.5%. Combine that with the MedArm filtering and it can even hit 90.4% in that particular domain. Across other tests you see smaller but still notable bumps. Pay preference might go from 64.7% up to 65.3%, or 67.2%. Pay correctness from 59.8% up to 63.2%, and so on. They say that overall, if you just do one pass, you get around 12% on average, but if you do 32 sample voting plus the MedArm, it pushes to 72.8%. 8%. Notably, these results beat some other large public reward models like Neutron 4340BR Reward 70.5%, and even approach or exceed GPT-40's 71.3% in certain comparisons. Now the system isn't flawless, of course it can stumble on tasks where only one correct answer exists, like math or coding, especially if no reference is provided. But if you give it ground truth solutions, it can nail over 90% on math, almost matching specialized models, generating detailed critiques instead of a single score. Can be slower in cost, more compute, especially if you sample multiple times to boost accuracy. There's also a delicate balance with the KL penalties set at too low and the model can misbehave. Ablation studies confirm that principal generation and rejective sampling are crucial. Removing them undermines performance. Still, the generative approach is flexible for everything from chat help to safety checks, and if you need more accuracy, you can sample repeatedly and let a meta RM filter out duds, all without retraining a bigger model. Now the rumor mill has also been churning about DeepSeek's next chatbot, allegedly called R2. The initial R1 was already a big splash earlier in the year, so everyone's curious if R2 is going to leverage DeepSeek GRM right out of the box, or if it's going to do something even more advanced. The company hasn't made any official statements on R2's release date or whether it will incorporate all the features described in the new paper, but there's definitely plenty of speculation in the community. On top of that, DeepSeek is talking about open sourcing these advanced AI models at some point, but again, no firm timeline has been released. Still, that's big news in a world where people are hungry for more open large-scale AI solutions. So here's how it all fits together. SPCT is basically the backbone of DeepSeek's self-improving model. Instead of just scaling up the model, they teach it to create its own rules, critique its answers, and give itself feedback if Its response matches what it considers a good answer. It reinforces that behavior. It's like a student explaining their answer and learning better through feedback, just way faster and automated. What makes this approach so flexible is that it works across different tasks without needing to rebuild the whole thing. If the goal is correctness, you feed in references. If it's about safety or politeness, you train it with those values, whether it's choosing the best of a few responses or judging a single one. It handles it all with the same architecture. Now what's really wild is that the 27B version of DeepSeek GRM with enough sampling and metarm filtering can match or even outperform giants like GPT-40 and Neutron 4340B in some benchmarks. That's huge, especially coming from a newer player backed by Tsinghua University, which adds a lot of credibility to their work. It also speaks to China's growing push to build competitive AI locally. At the end of the day, this whole setup is about smarter, more adaptable models instead of just going bigger. DeepSeek trains models to critique and improve themselves on the fly. The results are strong. The critiques are actually useful for devs, and the flexibility is a big win. It's not always the fastest method, especially with sampling, but it gives you a deeper level of insight and control. Alright, and just as DeepSeek's making waves with its self-improving models, OpenAI's got some big moves of its own coming up too. They're gearing up to drop a bunch of new AI models soon, and at the top of the list is GPT 4.1, a more refined version of GPT-40, their flagship multimodal model that handles text, image, and audio together in real time. GPT 4.1 is expected to take that core and polish it further, offering better performance across the board. We're also hearing that OpenAI is planning to launch mini and nano versions of GPT 4.1, which are likely optimized for speed and lighter devices. Plus, they've got something called the O3 model lined up, and an O4 mini that might even drop sooner. An AI engineer actually spotted references to these in ChatGPT's webcode, so this is probably not just a rumor. It's happening soon, maybe even next week. But now here's